and we have stopped somewhere where we were looking to techniques, where we start to look at the techniques of network security, especially in the cryptography. So three of them has been completed: cryptography, steganography. Yes, the third one was, what was the third one? Was it hashing? Yes, I think, yeah, the hashing. The fourth one is gonna be, no, yeah, it's not the hashing. What was the third one? Third point, which we have completed. Okay, what was the third point? Yeah, hashing is gonna be the fourth one. Cryptography, steganography, and the third was, what was the third one? Watermarking, and it is going to be the hashing. Okay, the hashing. All right. So yesterday we have seen about this hashing technique, a bit of it, how it's being used, and some of the content has not been discussed. So allow me to discuss with you today some of the content which we left yesterday. All right, so there we go. Let me show you the presentation for today. 1 second. All right, so okay, so I hope it is being shared. I think the screen is being shared with you, and we want to see something called the hashing technique, and we saw that in this hashing, hashing technique, it's a function which is going to take the input of any size and is going to give us a fixed output. We take any arbitrary input to form what? To form so-called the fixed output. Okay? That's the number one which we have seen from yesterday's class. All right? And we have said that this is one-way function. Okay, it's a one-way function, means you can't reverse it back. That's what is called one-way function. And we have seen some features, no? We have, yeah, the features, we have seen features that it is a fixed length, means the output should be a fixed length, means it should be a constant. Okay, it should be, it may be decided to be 32 bits, it may decide to be 128, it may be decided to be 256 or 512. Okay, or 512. So the output should be fixed, and the output is known as hash value. And the function which takes input to convert into the output or to convert into hash value is known as hashing the data. That process is known as hashing the data. All right? And another features we have seen that, again, the features is known as the characteristics. How it's being characterized. Okay? This also hashing function is sometimes called compression function. Why? Because this technique or this method takes any size, either big or small, and to give us the exact output, the compressed output. So that's why it is called compression function. And when we take hash function with the n bits output is referred to as n bit hash function. Okay, and these are the popular 160, 520. These are the popular hash values, means the output which are always being used. Okay, So we do this technique in order to secure our data, in a form of confidentiality as well as integrity. All right. And the properties are new. Yesterday we did not see the properties, so we are going to see some properties. This hash function, it has 3 properties. Property number 1 is known as pre-image resistance. Okay, the pre-image resistance, it means that once it is converted, it can never be reversed back. This is also being used to say, if you have an egg and you break it as omelette, you can't make it again. Okay? Pre-image resistance, hard to reverse a produced hash value. Okay? Number 2, second pre-image resistance. In this second pre-image resistance, I want you to understand as we go in this way, you are given input. And you are given also the hash value or output. It is not easy to reverse again, okay, to the same input as you are given. Though you have it, but you cannot be able to reverse it. In the sense, you cannot change, you cannot modify. You may modify in order to have a different output. But if you have an input and the output, always output will give the same input. So you cannot change, there is no modification, you cannot substitute, you cannot modify. Okay, that is known as second pre-image. First pre-image, you can't reverse. Here means you have only output, you have only hash value for the first one, for this first one. Second one, pre-image resistance, you have a 2. Input as well as output. So you cannot change the input. Okay? You cannot change the input. The third is known as collision resistance. Here we take 2 things. We take 2 inputs, okay, of any length. Okay? These 2 inputs of any length, they may have the same hash value, but it's difficult for you to reverse the second attacker. You cannot be able to find or to phantom another input. Same to that one, but here is multiple. You may have 2 inputs. Okay, you may have 2 inputs or 2 conversion data, 2 data to be converted. When you have these 2 data to be converted, it is hard and difficult for an hacker or attacker to do what? To give the different output. That one is known as a collision resistance. Collision means the 2 things cannot mean 2 things different. Should always mean the same. All right. And this is what we have seen for this hash. These are the 3. These are the 3 what? These are the 3 properties: pre-image, second pre-image, and the collision resistance. And remember, this is introduction. This is the foundation of what we shall see in the upcoming units in Unit 4. All right. So these are the hash function. We have seen this is the diagram. We take a message of any length to the hash function, and you are going to have so-called the hash value or fixed output. Same meaning. They mean the same, but it may depend on how you want to give it. As long as you mention this hash value, variable length or arbitrary length, okay, to the hash function. All right. So this is the same example. We have, what does it mean? This is the input to the function. It gives us the same exact output. Okay, it gives the same length output as this long or this lengthy message. All right, this lengthy message, same size. It gives us same size. If it is 16 digits, it's going to be 16 digits. If it is how many? If it is 1, 2, 3, 4, 5, it's around. This is around 40, right? It's around 40 is it 40, like a 40 hexadecimal numbers which you may have here. All right, so these are the output which you may have here. Same, regardless any size of the input, we are going to have a fixed output. Okay, now there is another thing called cryptographic tools. We have completed cryptography, but this is another thing for you to understand. In the cryptographic tools, we have some tools which are used to enforce the confidentiality, to enforce also the integrity of our data. Number one, we have something called a PKI. PKI stands for Public Key Infrastructure. This public key infrastructure, as I mentioned earlier, this public key infrastructure, it will act as a third party. Third party means a database or a key store. We will have like a key store where the multiple users, let's say these are the users which you may have here. These are the user 1. Let's say this is U1, this is user 2, this is user 3. Okay, they have to register themselves to this database. Okay, to this, let me call this a database where it's going to store key. This is a key center. This is like a C key center. Okay, we have the key distributed center, key DC, key distributed center. Okay, center, and another receiver, they may be to this side. Okay, they may be to this side. So this is the user. Let me call him as a user 4. Okay, this is the user 5. This is user 6. Okay, so all of them, they register themselves here. They register to this key distribution center, and this key distribution center is going to act as a third party. Let me call like a third party. Third party means to monitor how the key are being exchanged. If the key has a problem, the third party will be responsible, but he's not aware of message being transmitted. For him, is just to keep the key which are being shared. Okay, the key which are being shared publicly. All right, for the secure, for the proper communication. This is known as public key infrastructure, PKI. The second one for cryptographic tool, we have digital certificate. All right, this digital certificate, they are used to be encrypted. They are used to the given message. If you send a message, you have to send along with a digital certificate. A digital certificate has digital number, stamp, date. Okay, it's called a timestamp. Okay, and so on, and the name of the sender, the receiver, and so on. It contains all these things. Okay, for digital certificate, we shall see digital certificate as well as so-called I forgot this one, as well as so-called digital signature. Okay, these two, we shall see them in unit 5. All right, unit 5. So let's look to this example. As you remember, one second. Okay, good. Okay, now, as you can see to this example which we have here, as you remember, I told you a man called Bobby. These are the Englishmen, English. Okay, these are the English people, UK person. Bobby and Aris. They used to have a conversation. They were a couple, which they had to have a conversation. So they used to encrypt the message because of the neighbors or because of those who want to listen to their messages. So this example, it combines whatever we have seen in this diagram as you see. This Aris want to send a letter to Bobby, and this is a plain letter. This is a letter. Okay, this is a message to be sent. This is a letter. So this letter is we are going to apply so-called hash. This is process number 1. We are going to apply so-called hash algorithm. You remember the hash means we are going to have the single output. I mean, we are going to have the fixed output. Let's take an example. This data is contained by 500 MB. Let's say this is a file which is sending quarter statement. Let's say 500 GB. Can you imagine? Let's say 500 GB. This 500 GB is going to be hashed, and then you are going to have using MD. Okay, using MD. Message MD stand for message digest. Okay, is a message digest. Message digest. All right, the message digest. Remember, the hash value is going to be called message digest. Okay, MD. All right, this message digest, it can be 128. Remember, it's a fixed output, 128. In this 128, we also want to apply some encryption. We have to apply encryption by providing the key to the encrypted message. After encrypting the message, we have to send along with the digital signature for not changing or for data for integrity. No modification should happen. If the encrypted data may be found, for example, you may get this one, okay, you may get this one, okay, but you want to change it, to modify it, and you have to put digital signature along with the certificate, okay. This is going to be sent. The message now is sent along with the digital signature here, all right, digital signature, and this digital signature is going to be received as input to Bobby, and the Bobby is going to do the decryption, is going to again to do the decryption to see if the data was correct by using public key. Remember, the public key they are in a PKI, public key infrastructure in that database to manage them, because the key are public. Okay, if all are matching, then the message is going to be, if all are matching, message is going to be accepted, or message is going to be sent to Aris. Hey Aris, the message is modified. Okay, the message is modified. Or hey Aris, the message is not modified. Okay, so he will compare two copies, what Aris has sent and what he has, then he is going to confirm the message. So whatever we have seen, it's all combined in this diagram. So this is an example. This is a brief of what we shall see in all, steps as we continue to go for this cryptography. Is anybody has a question before I do one more work here? I have work to be done for you. All right. So, is there anyone has a doubt? Okay, fine, good, good. I want all of you to on your videos, please. Come all of you to video mode. Come all of you to video mode, please. All of you come to video mode. I just want to see all of you on video mode because, as I said, we have to do one work, okay? We have to do one work. Come to video mode. I just want to see all of you to video mode, okay? And as you come to your video mode, yes, take your book along with, yes, Prince, I have to see you. Delton, I have to see you. Biswajit, yes. Take all of you your note. Take your book, take your material, whatever. All right? Take your material, whatever. We are going to do a very interesting, rapid fire. It's going to be the rapid fire. Rapid fire. And, oh yes, Sailam, I have to see you. By the way, I forgot. Sushumta, where are you? Happy birthday. A very, very happy birthday to Sushumta. Today is her birthday, right? I forgot. Oh my. Prince, when is yours? Prince, when is your birthday?
Sir, 8 March.
Huh?
8 March.
Oh, okay, okay. Somebody has said you have also birthday on this. Maybe because they say 8 March. It's gone. Okay.
Yes.
All right. So all of you, please come to video mode. I just want to give you one work here to be done. And okay. Okay, I just want to see some are there. Milton is there. Okay. All right. So let me come to this. Okay, as you are joining. So we are going to recap. Okay. the first recap we are going to do is I will be picking a name, and the name which I'm going to pick is going to answer. So all of you, I have prepared 2 marks question, okay? It's going to be 2 marks question. I'm going to start from Gokur Pant. The first question is going to go to Gokur Pant. Okay, the first question goes to Gokur Pant, and the second will be to Biswajit. All right, Gokur Pant. Okay.
Yes, sir.
Okay. What are the techniques to achieve security goals? Gokur Pant. Rapid fire. 3 seconds.
Confidentiality, integrity, availability.
Confidentiality, availability. That's the technique to achieve security goals.
These are the goals, sir. These are the goals. These are the security goals, sir.
Then I'm asking the techniques to achieve it.
Techniques, cryptography, stenography, watermark, hashing.
Good. One more is missing. What is that? Good.
4 only, sir.
Therefore, cryptography, watermarking.
Stenography, hashing.
Good. Excellent. Good. Good. Very good. So we clap for you. Then you can do the clap. The clap for Mr. Roshan. There we have my clap. Is there? Is there here? I do clap for Mr. Roshan. Applause to Mr. Roshan. Good. Next, Biswajit. After Biswajit, we have Mr. Lakshit. Okay. Next, Biswajit. What is the need of network security? Biswajit. What is the need of security? Network security. What is the need of security? Network security. Biswajit. Go fast.
To protect the data, sir.
Excellent. Good. Excellent. Good. 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 And Mr. Lakshit. Okay. Specify 4 categories of security threat. Specify 4 categories of security threat. Yes, Lakshit. Specify. And after Lakshit, I'm going to have Litik Mehta. Okay, Litik Mehta is going to be followed by Prince. Okay, Lakshit first. Specify the what? Specify the
threat to confidentiality, threat to integrity, threat to availability.
Good, excellent, good, very good, very good, excellent. Litik Mehta, define stig analysis. Define stig analysis. Litik Mehta, question. What is stig analysis? Stig analysis. Litik, you are not moving. Can you move like this? I just want to see if you can move. You are paused. Maybe you can't hear. Okay, Litik is not there. Prince Kumar, Prince. This is Biswajit.
Sir, I have a bad internet connection, sir. My video is keep on pausing.
Oh, okay. Okay, who has answered this one? This was Lakshit, 2 marks. This is Mr. Lakshit. Okay, Lakshit. This was Biswajit. Biswajit. Yes. Yes, please answer. What is this? This is.
I answered, no, sir.
Litik. What is Litik? Has a network issue. He says has a network issue. Prince Kumar, you can answer this. Yes, Prince.
Yes, sir.
Define stig analysis.
Sir, to detect the presence of hidden information in a stego object.
To do what? I couldn't.
To detect the presence of any hidden information in any steganographic image or object.
Okay. Okay, to detect it. Okay.
And destroy it or
destroy it. Okay, something is missing. Is a half. You want to detect it without prior information. Okay. without knowing the keys which has been used. Okay, you should not forget that one. I give you 1 mark. Okay, next question is going to be to Jivan. List different security mechanism. List the different security mechanism. Jivan first. List, yes. You are mute, you are mute. Yes, Jivan.
Security mechanism.
List the security mechanism first.
Sir, someone is mute.
Who is muting you?
They muted, sir.
Who is muting, please? You should not be muted.
Someone is muting, sir, repeatedly.
I will check, I will work on it. Yes, go ahead.
Encipherment, sir.
Mm-hmm.
Access control.
Mm-hmm.
Someone muted again. Sir, someone muting.
No, you are mute. Who is muting? I just want to see.
Again, they muted, sir.
No, you are unmute. You are unmute.
Yes, sir. Encipherment, access control.
Mm-hmm. Again, it's being mute.
Sir, again they are muting, sir.
Oh, wait 1 second. 1 second. I just want to figure this out. Okay, so said I will check. I will check this after, right?
Okay, sir.
Yeah, I will check this after. Yeah, please don't play with that one. Don't play that game.
Encipherment, access control, notarization.
Okay, sorry, I will work on this security because I can see you are, you are taking this to another level. Okay, and
Sir, they are muting, sir.
I have to check. I have to work with the administrator to work on this one. Okay. So the next question, let me ask this one to Litik. Are you there?